So more and more, we are getting larger data sets to work with. When we go and do drone surveys, we might, instead of getting a few 100,000 points or 1 million points, we might end up with 100 million or 1 billion points. And it becomes a bit of a chore to work out how to get those into a piece of software such as Mark 3D quickly and efficiently and at the level of detail that you need to accomplish whatever task you're working on. So in this example, I'm just going to go through and pull in a drone data set. There's about 65 million points in this. These are a set of LAS files, so it's the survey's been chopped up into little pieces, and instead of just getting one giant LAS, we end up with a whole lot of them here. And some of the challenges is working out how to pull in all that data. Maybe we're only interested in a certain region of that data. We don't need to pull in everything. And how do we thin that out and turn it into something that we can use for modeling in Mark 3D quickly? So I'm going to do that today using some of the commands in the data import menu and just a little bit of Python scripting. So the first thing I'm going to do is I'm going to write a little script to work out how many points are in a single LAS file. I'm going to do that I'm going to record a macro here. I'm going to call this count points. So now my macro is being recorded. So the first thing I'll do is go to the data import menu and go to LiDAR, and I'm going to run inspect LAS file. And this command just prints out a bit of information about what's in a certain LAS file. So I'm just going to choose the first one here, hit OK. It's going to print some information out to the output window here. Number of points is 51,000. So we could go through and run that command for every single one of these files and add it up and then work out how many points there are. That's really boring. It's going to take a bunch of manual work. There are better ways to do it. So I'm going to end my macro recording now. And here's my macro. So all it's doing is going through, it's inspecting the LAS file, and this is the file name that I selected. So when we run this command in the macro, it returns a result value here in a variable called result. What I'm going to do is I'm just going to print this out just to see what's inside this value. Maybe there's something useful we can use. I'm going to come back and run count points. And we can see here, the command output is still printed to the window, but down here we have the result value that's printed out. And this is a Python dictionary, which is a set of key and value pairs. So for example, there's a key called point count, and the value of it is the number of points, 51,072. So I can get that value out of the result field here by accessing it using the square bracket notation, and then the name of the key, which is point count. And so when I run this should just print out the value for point count. So I'll save that and run count points. And here we are, there's the number of points in this particular file. So now I've got the value for one file. I want to do that for all these files here. So to do that, I'm going to create a loop that loops through all the LAS files in this directory, and then puts, as it's looping through, it'll create a variable, and we'll use that variable here for the file name. And to get a list of all the LAS files here, we're going to use a Python module called glob. That's G-L-O-B. And this is just a command where we give it a wildcard piece of text, and it'll go through and find all the files that matches that piece of text. So we're going to do this in a Python for loop. And I'm going to create a variable here called file name. So in glob, within that module glob, there's a function called glob. And then we just give it a pattern, so star.las. So that will match anything that basically ends in a .las extension, which is going to be all of these files. So then I put my colon, and so to tell it what code to run inside the loop, I indent this and replace this result, the file name here with my variable file name. So the other thing I'm going to do, so this will print the result, the point count out for every one of these files. But these values are going to get lost because it's going to print out the text and then the point count and then the text from the command and so on. So I'm going to actually create a variable here and to sum up the number of points in total that we've got here. So I'm going to create a variable called point count, and I'm going to set it to be equal to 0. And then here, instead of printing the result, I'm just going to say point count. I'm going to increment that, so plus equal means increment it by a value and by the number of points in each file. And then down the very bottom here, I'm going to print the point count. So this will go through, load up each file, count the number of points, add it to the point count variable, and then at the very end, it'll print the total point count. So we can just run that again. So here we have it. We've got 65 million points in these last files. So that's too many points for us to work with. So the next task for us is going to be going through and decimating that, just so we can, at least as a very first step, we want to see the data. So we're going to pull in just a subset of all that data, just so we can look at it and decide if it's what we want, or if we want to pull in just a part of it. Okay, so to import the data, we're going to create a, we're going to record ourselves loading up some last data in a macro, and then we'll use that and paste it into our code. So I'm just going to create a new macro. I'm just going to call it _tmp. The underscore will kind of make sure it sits up the top of this directory here, and hit OK. So to import the data, I'm going to go to data import, LiDAR, import last file. Choose, again, I'm just going to choose a file name because ultimately I'm going to stick this inside a loop. In this case, these last files only have a single classification of points, meaning they've not been classified. And we're going to preview the file. So this is preview file option is just a way of thinning out the data. It's going to bring in every 10th point in the data set. This is a really crude way of decimating data. But remember, at the end of the day, in Muck3D, we're going to take this data and we're going to grid it. So even if we pull in every single piece of data, we're going to lose a lot of definition once we grid it. And so generally, this is an acceptable way of thinning out the data given the way that we use it here. So I'm going to hit OK. And there's my data set. I'm going to end the macro recording. And so here's my importing the last file. So I'm just going to copy that. And I'm going to come back to my count points here. And I'm going to paste that in here. So I'm going to create another loop here, doing basically the same thing. So I'm going to just copy this stuff because I want to run through and load up each of these files. So I'm going to, every time we do this, we want to run this import last file. We're going to change the file name here to be our variable file name. Now, in total, we've got about 65 million points. And so therefore, just to preview the data, we want to bring in maybe 650,000 points. So we're going to bring in every 100th point to start with. So we'll change our sample rate here to be 100. And so, so in this case, there's 51,000 points in this first file that we loaded. That'll bring in 510, which isn't very many. But again, we're just doing this so we can see the data. And again, in the macro here, this line, the classifications, the only thing that's important here is the classification number. So 0 means never classified. And this point count here, it doesn't matter whether this is the correct one for the file or not. That's just a piece of data. It's not actually read by the macro. The important thing is this true, which means import the data from classification 0. So now I'm going to run this. I should see all my files loaded to the 3D window, and I can see the data set. So I'll just start by clearing graphics and just make sure I save this. And then I'm going to run count points again. So it's going to go through and count all the points. And then it's going to come through and then import the data from each of these layers. And so this should be our 650,000 points or so. So if I just go to info and scene info, I can see I've got basically 1/100th of the number of points that I started out with. So if I wanted to make a surface out of this, I just need to put everything in a single layer because when we create a surface, it has to come from a single layer. So I'm just going to merge visible layers. And so this is just going to leave us with a single layer that's got all this data consolidated into it. I'm going to do surface, create surface from layer. I'll just hit OK. And there's my data set. So, very quickly, it's easy for me to load up this data and just see what I'm looking at. I might do this and realize that this isn't actually the set of tiles that I want, but I haven't wasted a whole lot of time trying to import them at high resolution to kind of come to that conclusion. Okay, and just to finish off this little exercise, what I'm going to do is just suck down an air photo for this. I don't happen to have a georeferenced image for this handy. I could probably go into USGS and download something from Landsat or something like that. But I can also use some of the web map servers or tile servers that are available to grab an image. So this command here, download TMS tile for geometry. We just need to tell it what coordinate system we want the tile to be in, and this one happens to be UTM zone 15 north. We tell it the provider we want to get the satellite image from, so there's Bing, Esri, Google Maps. I'm going to just pull in a Bing image, and the zoom level. These tiles can come in at different resolutions, and the larger the zoom level, the higher the resolution image. We don't want to try and download a super high resolution image for a large area. That will take a very long time. I think we're going to do about a zoom level of 17 here. And I'll just call this air photo. And hit OK. I just choose my surface. It will go to the tile server and then download the tiles, stitch them together, and then it will drop it on top of my surface here, and then save the air photo and the georeferencing information in my working directory. So there's my terrain model with my air photo on top. So I could look at this and come back and decide if I want to pull in more and more data. I could change the thinning, the amount of thinning that I do with the data import, or this might be adequate. But anyway, this is just a way that we've turned 65 million points into something that we can grid and get working with in a few minutes. So I hope this helps, and we'll go through some more examples on pulling in data sets just within specific regions, and some other cool stuff we can do with Python and data processing.